So we've been working on limits, and we've learned about left-hand limits and right-hand limits, and we've seen how sometimes the limit exists and sometimes it doesn't. All right, and now we're going to look at what happens when infinity is involved. All right, so let's look at a function very similar to ones we've looked at before here. If we have as x is approaching 3, remember this guy means 3 from the left side of this function 1 over x minus 3. So hopefully we have an idea that the function 1 over x minus 3 has an asymptote at 3 because that's not removable. And we've got a hyperbola that looks like this. So the question is, what happens as we approach that from the left? So as we get points on the graph that have an x-coordinate that's closer and closer to 3. Well, we can kind of see that it's dropping down. The y value is dropping down to infinity. So we see that from the graph, all right? It's useful to be able to get that with a little bit of arithmetic and just kind of have an understanding. So let's think about it. From the left side of 3, we're going to have something like 2.9. When you put 2.9 in here, well, that's going to give us 1 over 0.1, which is 1 over a tenth. And 1 divided by a tenth, if I multiply this by 10 on top and 10 on bottom, that'll move the decimal point. And this is just 10. All right, so 1 over 1/10 is 10. Okay, so 2.9 gives us a value of 10. And then if we have 2.99, then this fraction becomes 1 over 2.99 minus 3 would be a negative. That last one should have been negative also, all right? 0.01, which is 1/100th, all right? And so we can multiply top and bottom by 100, and we'd get negative 100, all right? And if we kept going farther and farther and farther, this would be 0.001, then we'd be looking at 1,000. This number is getting very, very large in the negative sense there, right? So this is going to infinity. Now, it's important to understand that this really means that it doesn't have a limit. It never is going to end. It doesn't have a bottom or a floor. So, but we have a special limit, negative infinity. Don't forget that negative like I just did. All right. And what happens when we're coming from the right side? Well, that hit there, we're shooting higher and higher. So this would be like numbers like 3.1. And when you subtract 3.1 minus 3, this becomes 1 over 0.1, which is 10. And if we have 3.01, which is really close to 3, this is going to be 1.01 when you subtract it here. All right, and that's going to be 100. And so on and so forth. So this is going to get larger and larger. So this is going to go to infinity, and we can also see it from the graph. So these are our infinite limits, all right? So again, keep in mind that if we have a limit equal to infinity or negative infinity, it doesn't mean that the limit exists. It just kind of gives us a general trend of what's going on. Well, that's when the y value goes to infinity. What happens when the x value goes to infinity? Can we find if the limit exists or not? Well, let's find out here. Okay, so we got a function 4 over x minus 5. And hopefully we've got a picture in our head, 4 over x minus 5. We should say, well, that's going to have an asymptote at 5, right? So, yeah, something like this. Here's a Desmos version. We're going to asymptote at 5 there. Okay, and it's going to look like that. But what happens as we go to the right? What happens as that goes to infinity? Well, as x gets bigger, we've got 4 over 100 minus 5, 1,000 minus 5, 1,000,000 minus 5. This number right here is going to be getting bigger and bigger and bigger. When you put 1,000,000 in, we've got 1,000,000 minus 5, 1,000,000,000 minus 5. So this is 4 over a very big positive number. And 4 over a very big positive number is really worthless. Even though that's 4, when you've got 1,000,000 or 1,000,000,000 or 1,000,000,000,000 down here, 4 over 1,000,000,000,000 is pretty close to 0. So this is getting closer and closer to 0. Okay, so notice, by the way, this 5 doesn't really even matter. All right, so as we get closer to infinity, that 5, even though, it's something, but it just doesn't matter that much. So it's really the same as 4 over x. Okay, it acts like that. What happens here when x goes to negative infinity? All right, so if we put negative infinity, remember that when we put negative into something cubed, it's going to be negative, right? So, whoa, this is a big number. We've got 2 million here. That's pretty big. So if I put like -1 in here, let's start with -1. Well, that's going to be like 2 million over -1 cubed, which is -1 minus 2, that's -3. Well, that's a pretty big negative number. Okay, 2 million divided by -3, right? But what happens when I put -10 in here? Well, -10 cubed is -1,000, so now we're talking -1,002. Well, all right. 2 million divided by 1,000, not that big anymore, all right? And as this number gets bigger and bigger and bigger and we cube it, this number down here is going to get huge, okay? And in fact, if I plug in -1,000 and we cube it, that's going to have 9 zeros now. All right, and all of a sudden, this number on the bottom is a lot bigger, and this fraction is less than 1, actually less than -1, between 0 and -1. Okay, so even though this number is real big here, this number is getting really big, even faster. This is staying put. So pretty soon, this number is going to be 1,000,000 or 1,000,000,000 times bigger than this. Or it's going to grow. We're going to infinity. Now notice I ignored this 2, because does it really matter when I'm just thinking about how big these numbers are? If I subtract 2 from this and get what, 999999998, does it really matter? No. Okay, so the 2, to figure out what this is going to, that little baby 2 doesn't matter. In fact, it really doesn't even matter that this thing is 2 million. We could think of this as a 1. So really, this turns out to be the same as the limit as x goes to -infinity of 1 over x cubed. Those other things don't matter. They're constants. Eventually, they're so much smaller than the number that we're plugging in. And so this, when you plug in larger and larger negative numbers here, this is going to go to 1 over a big old number, which is 0. Okay, a small number over a gigantic number is getting close to 0. So that's the idea, right? We could think what happens there, and those small numbers go away. So the key point here is that when x becomes very large, whether it's positive or negative here, other smaller numbers become worthless, all right? So small numbers become worthless there. And so, wait a minute, 2 million, that's small? Well, it is when you're talking billions and trillions and billions of trillions, and this number is getting so much bigger. Who cares about 2 million when you have trillions and trillions on the bottom? All right, so you can think of it this way. Suppose we had $1 trillion. We won $1 trillion in the lottery. That's a big lottery. So $1 trillion, well, that's this big old number right here. All right, 12 zeros. What would you care if you had this $1 trillion and you lost $1? No. All right, you'd probably blow your nose on a dollar bill if you had to, right? What if you lost $100 bills? Well, you've got so much. You just won $1 trillion. Who cares about 100? Who cares about 1,000? Is 1,000,000 even that big? Well, 1,000,000 isn't really that big. You could give $1 million to your friend just for kicks, because this is really 1,000,000 times 1,000,000. You have 1,000,000 millions here. That's what $1 trillion is, all right? So 1,000,000 millions. So if you lose 1 million, that's okay. You still have a lot of millions left if you had this big old lottery win, okay? So the idea is this: when you're working with rational functions, as x goes to 0, the small terms don't matter. So you can eliminate them to get a simpler limit, all right? So let's see here. as x goes to negative infinity here. All right, so x is going to, it's going to be a negative a million, negative a billion, negative a trillion, so on and so forth. So if x is a negative a trillion, does this 7 really matter? No, that 7 doesn't matter. It's small potatoes. When x is a trillion, does this 4 really matter? A trillion minus 4, you lost 4? No, who cares about that 4? So this limit is equivalent to the limit as x goes to negative infinity. That's all the same. 3x over, and this is a negative 5x. Well, what's happening there? Well, since we don't have anything else, we can simplify that. Okay, we couldn't simplify this fraction, but we can here, and we can see, well, now really we just have 3/5. So x is going to, well, negative infinity, that doesn't matter anymore because the x's are going away, but we got negative 3/5. Don't forget that negative on the bottom. And that's the idea. All right, a couple more little examples here. What happens here? Well, x is going to positive a million. Same idea. If you got positive a million, does this 5 matter? You lost $5? No, that doesn't matter. Does this 4 matter? No way. Who cares? I got $1,000,000,000,000, right? Okay. Limit as x goes to infinity of, got to keep that negative, that's a minus x or a negative x, all over 3x. And what happens with these x's? Well, they're going to cancel. Don't forget to leave 1 behind. There's a 1 there. And so this is going to be just negative 1/3. All right? That's the idea. A couple more quick ones and we'll wrap it up here.